Good morning and welcome to this third session of PV Magazine Roundtables Europe. My name is Mark Hutchins, Magazine Director here at PV Magazine, and it's great to be back in the studio again for yet another huge Roundtables event. Please do check out our schedule for this afternoon. We have a full day of discussions, 5 more sessions to come after this one, and we're covering really every aspect of the solar and energy storage industry in Europe and beyond. Right now, though, it is my pleasure to welcome you to this session titled Leading Edge, What's Next for Solar Cells. And as we just heard in the previous session, we've seen fierce competition and rock-bottom prices in the PV module market for more than a year now. And this means manufacturers are highly motivated both to cut costs and to push for higher energy yields. And there are plenty of routes they can take to achieve this, as we will hear over the next hour. Tunnel oxide passivated contact, or TOPCon technology, today accounts for around 70% of the module market and is set to grow further to around 80% in 2025, according to numbers kindly provided by InfoLink Consulting. And the manufacturers behind TOPCon still have a few tricks ready to push for higher performance. But 2024 has also seen big achievements with back contact and heterojunction cells, and these are increasingly seen as viable, cost-effective routes to significant performance gains. This year has also seen the first commercially available modules integrating tandem cell technology, and while most still see a few challenges in the way before these have any chance to make real market impact, these early movers have an important role in forming the size and shape of those impacts, and all in the PV industry will surely have an eye on their performance out in the field. Coming up this morning, I will be in conversation with Johanna Bonilla of JinkoSolar, and we have presentations from Trinasolar's Mireia Beltrá and LONGi Solar's Chaowei. That's before we head into a panel discussion, bringing some of these manufacturers' viewpoints, together with those of an expert market analyst in Molly Morgan of Crew Group, and a leading PV researcher in Oxford University's Sebastián Bonilla. Our first presentation for this session, though, comes from Jason Xia, Module R&D Director at Tongwei Solar, who is treating us to a look at some of the innovative processing that goes into its latest modules. Jason, welcome, and over to you.
Thanks for the introduction. Can I control my screen?
Yes, we can see and hear you. You're good to go.
I'm sorry, I cannot control my screen. I want to go to the next slide.
Okay, sure. Well, yeah, we'll get Jason online as soon as we can. Do we have one of the others lined up? Okay, sure. Thank you. Well, yeah. Back to Jason shortly. Hopefully, we can get that fixed. Then the next segment. I am delighted now to be joined by Johanna Bonilla, Head of Technical Product Management for Europe at JinkoSolar, for a quick look and a chat about Jinko's roadmap for cell technology. Johanna, good morning and welcome.
Good morning.
Now, Jinko has been among the biggest backers of TOPCon technology in recent years. Will that still be your main focus in 2025?
Certainly. We are quite confident of TOPCon technology, so it is evident that the technology itself have grown very fast, has also lead the growth of any other processes in the cell production, in the model production. And we are quite confident also that TOPCon has room to go. So we are working in several steps to improve efficiency, to change features at module level. But definitely TOPCon is something that Jinko trusts and will focus in the coming years for sure.
And in 2024, we saw a few significant improvements with TOPCon technology. What do you see as the most important so far?
Well, I will say that there are things that we don't see, especially in this industry. The final result is the module, but at the wafer level, for example, especially the rise of M-type silicon make a lot of improvement in the wafer quality. We have tighter control of the oxygen content, for example. We have shift towards using ultra high purity silicon. So this is going up to 9, which means 99.9% of purity. This is compared to levels of 8N or something different that we used in the past. The wafer cutting, for example, have been also improved. The industry has fully transitioned to diamond wire sewing. These have brought a lot of substantial gains and also material costs lower. And this is very important for the industry. But I find very interesting that if we see the development of TOPCon in the last 10 years, and especially in the last 3 years, we have improved and evolved very, very significantly in terms of efficiency. I prepared some slides, but I don't know if you can see them now, but to show how fast and how often we have improved, especially what we call passivation. So the passivation system have clear advantage compared to PERC in the past, and we have improved rapidly using laser metallization, lighter doping, lighter doping diffusion, structure optimization. So passivation have been key for TOPCon, for example, compared to other technologies in the past, and is where we think we have still a lot of room to improve. Optical improvement has also become very trending, I can say in that way. We have switched to a small size pyramid in the structure. So there are many little things that we don't see at the module, at the final result, that we may not perceive, where I think TOPCon has been a key for improving at the industry level. And of course, now we also see the push of the market, and especially because of environmental issues, to put all of these technologies together and to have further developments that are more climate oriented or risk oriented. We see a lot of increase in hail, a lot of humidity increase. So all these changes also coming from the nature and from the client's requirement has led also to more specific development of modules. This is what I can, perceive.
Sure. And when we look at TOPCon technology, what is still to come? Is this reaching close to its limit in terms of efficiency and performance, or is there still more we can do to push further?
Yeah, so the efficiency limit is not reached yet. This is something we can confirm. So we think we have still room to go. So our target clearly next year is to have at mass production 27% of efficiency at the cell level. And we have, as I mentioned, a lot of room, especially for the passivation part. So we have passivating contacts with metal electrons for silicon surface that can reduce recombination still. We have some material innovations, so we can use certain films to enhance anti-reflection. At the silicon cell level, we have optical improvements, so there is a lot of discussion about photonic crystals, reflected index improvement. We still have room to go there, but I think in the upcoming years, metallization will be key. There are a lot of discussions for new materials emerging to reduce costs also, but also to improve long-term reliability. So I think that we have a lot of features internal from the module to give us room for TOPCon, at least for the next 4 years.
Sure, but when you look at Jinko's technology roadmap, are there other silicon cell technologies that you're evaluating on there?
I always like this question because at the R&D we do crazy things and we have a lot of testing in different technologies, but definitely we focus on TOPCon. Our latest records already in R&D are based on tandem, where we still use TOPCon as a part of the tandem layers.
And when it comes to tandem cells, what do you see as really the main challenges that are still there?
Yeah, well, I think that tandem has still, we have a lot of potential in tandem. We have theoretical limits of 45% or higher. So we really trust that this is the next generation. However, reliability, stable scaling process, especially to perovskite, I will say economic cell to module design, system designs are very challenging. So we have an opportunity that we see it around 2028, 2030, but we still have a lot of challenge to go.
Okay, and we should be able to see your slides on the screen as well, Johanna, if you can.
Yeah, sure.
If you wanted to quickly run through those, yeah.
Okay, so I think I will need to move very fast because we talked about some of the topics already. Maybe we can move to the latest. I'm trying to move. So yeah, we talk about what wafer have changed, but I think that it is important to focus on the latest part. This part is the very important part of perovskite, where we are seeing, as I mentioned, the potential, but also the challenges of perovskite. But when it comes to the industry level, and this is why we trust still in TOPCon, right? Is we see that the upcoming years will be focused on TOPCon. We have still room to go. So here I'm showing you our latest R&D results, where I mentioned already we are using tandem with perovskite and TOPCon has our key part, and this is one of our latest records, right? And it's not the latest one because that one will be published in a paper, and I didn't want to crash on it. But basically, we see, for example, that the thermal stability of TOPCon structure allows us to have thermal treatments of recombination layers, and this is very key for tandem. So this can lower the resistance and higher the transparency. So very important. This is why we still work on TOPCon. And many things that are happening in these tandem structures, like the use of TCO, also with high temperatures, are an advantage for TOPCon, right? And yeah, this is why we really think that the process of high temperature deposition of TCO is compatible with TOPCon bottom cell. So I wanted to show some of our progress, but yeah, for sure we have some years to go with TOPCon. And I mentioned already passivation, metallization, and some layers improvement still give us room. And for sure we see that the next step in 5 years around will be tandem.
Mm-hmm. Well, thank you very much, Johanna, for joining us this morning. And please do stick around for the panel discussion that's coming up a little later.
Thank you so much.
Right now, though, well, I believe my excellent colleagues behind the scenes have managed to fix the technical issue that Jason was having previously. So let's see if we can get his presentation on now. Welcome, Jason. Thanks for joining us, and yeah, over to you once more.
Yeah, thanks for the introduction. My name is Jason Xia, and I'm a director of the module R&D department at Tongwei Solar. My presentation covers the progress of Tongwei Solar's N-type solar cell and module. So looking at the company's PV industry chain, we have the world's largest polysilicon capacity, currently standing at 650,000 tons, a figure which is will reach around 1 million tons over the next couple of years. Our ingot and wafer capacity are 20 gigawatt. Our new N-type solar cell capacity right now is more than 100 gigawatt, with company ranked #1 for global cell shipments for 6 consecutive years. Module capacity and is about 80 gigawatt. We have just built Tongwei Global Innovation R&D Center by Q3 of this year, with total R&D workshop of 108,000 square meters from T1 to T6 fabs. And we have the polysilicon solar cell PV module and lab facilities. And technically, for HED, we started China's first gigawatt HED production line in 2021. And then we built a new R&D lab on advanced materialization, primarily for HED in Sichuan, also in 2021. And then we have introduced the most advanced HED production line with 100 gigawatt in T6 fab in this year. For TNC, that means Tongwei N-type cell. We set up a G12 wafer size R&D line in 2020. We also have a dedicated pilot line for IBC development and well-equipped perovskite and HED tandem developed lab. We spent tens of millions of RMB to build solar cell characterization lab. Till now, we have two module pipelines in Anhui and Sichuan province for shingling and half-cut module technology development. Meanwhile, a reliability lab with area of 12,000 square meters with CNAS certified and TUV witness is established in this year, which should be the largest reliability test lab in the world. And Tongwei has over 1,200 R&D researchers covering all PV technology field. Tongwei has already published nearly 2,500 patents by Q3 of this year. And for R&D sector, we have covered all the technology roads of crystalline silicon cells and module, including HED, TOPCon, BC, perovskite, and HED tandem technology. Actually, we have invested in R&D activities to keep ahead in each road in the industry. Tongwei initiated TNC cell research in 2020 and developed the industry first large wafer size PCVD polysilicon technology road. By 2021, mass production cell conversion efficiency has reached 24.65%, with this further improving 25.3 in 2022 and more than 26.9% in this year. As far as technical innovation goes, tube-based PCVD technology is a highlight developed by Tongwei in collaboration with Nantong University and Lead Micro, and has been twice featured in annual and monthly cover articles of PIP. The domestic collaborative development achievements in tube-based p-titanium oxide poly has closed the industry gap and enabled TOPCon cells to benefit from cutting-edge developments and industrial leading production processes. So if you can draw your attention to the screen, you will find our flag products, which we named the Tongwei Jin Repower N series. The product design is based on G12R and G12 size cells. Residential applications are covered shorter, less than 2 square meters, aesthetically attractive. So the all black module, the power is up to 455 with commercial and industrial and utility application catered for by the longer modules with output of up to 515 and 630. And also we have the G12 module. The module power can reach 725 watts. There are three core innovations for HED technologies. The first is the bifacial nanocrystalline passivation. So for the high efficiency and also the copper interconnection for both silver-free and high efficiency. And for the module technology, we have the zero busbar technology for the higher power and reliable outdoor performance. Tongwei began developing HED technology in 2018 and building its gigawatt-level HED production line in China in 2021, as I mentioned before. And Tongwei pioneered the introduction of bifacial nanocrystalline silicon into HED. Therefore, by Q1 of last year, HED champion cell efficiency reached 26.49%. So with HED technology from wafer to module developing accumulation, we have break Tongwei's HED module power records for 9 times, from about 720 to 776, which is certified by Chaowei. And that's all. Thank you for your time.
Thank you, Jason, for sharing those insights with us. Now, you mentioned copper interconnection in there. As I understand, it's quite a challenge with those copper plating processes to avoid damage to the cells during the process. How do you handle that at Tongwei?
Yeah, that's a good question. So because the damage to the HED solar cell in copper plating process is mainly due to the TCO film layer. So the PVD sputtered TCO is mainly amorphous, which is less effective in blocking copper atom ion diffusion and released acid corrosion. So the Tongwei solution is first we enhanced the annealing, improving the crystallinity and corrosion resistance of TCO. And second, we reducing the sputter power and thickness of the copper thin layer to achieve a balance in physical damage and adhesion. So the last one is we replacing copper with alloy materials. In addition, Tongwei did not identify any other significant damage related to the copper plating process.
Okay, well, thank you very much, Jason Xia, for joining us this morning. Right now, though, we head straight into another short presentation, and moving back to the theme of TOPCon and its further potential, we have Mireia Beltrá, Product Manager for Europe with Trinasolar. Welcome, Mireia, and over to you.
Hello, good morning. Thank you very much. Okay, great. I can see myself and I can see the screen now. First, let's see. Great. Thank you very much for giving us the opportunity to explain how we see things moving forward at Trina in terms of cells. Sadmira, my name is Mireia Beltrá, and I'm part of the product management team here in Europe. So in terms of cell technology, I wanted to start with the headline, but it's quite aligned with what my peers said before. What we see for the next 5 years at Trina as the mainstream technology is TOPCon, right? This is what you can see in the slide. So it's aligned with somewhat of the consultancy companies are also expecting for the coming years. Why is that? I would say for 3 main reasons that were already mentioned before. One is the maturity of the technology. Right, so this is already, we've been manufacturing TOPCon for several years already, so it has a very good level of industrialization. The supply chain is very mature. The product is it's mature in terms of reliability. Reason number 2 is the LCOE. So what we see today for most of the projects, considering the cost and the energy yields provided by TOPCon, we see that it's the product the technology that fits most of the projects. And number 3 was already advocated by Johanna, it's the room of improvement we see for TOPCon in the coming years. So combining these three reasons, it's what make us take the decision to move forward with TOPCon. Coming back also to the point that was raised before is, are we investigating other technologies? Of course, we see also, and it's also something you can see in the slides, small rise for back contact, heterojunction, which are very interesting technologies. I don't think there's a perfect, that we at Trina, we don't think there's a perfect technology for every project and segment. We think though that TOPCon covers most of the scenarios, and this is why we see TOPCon as the mainstream for the coming years. If we deep dive a little bit more on the way we've been walking in Trina with TOPCon since 2015, we started delivering the first projects 2019. It's been with us here in Europe since late 2020, early 2021. And the first stage, let's say what we call the TOPCon Plus. Currently, we are at the third stage of the TOPCon technology at Trina, is the stage we call the advanced. And this is the stage at which the technology has become mainstream for our customers. So just to give you an idea, here in Europe, it was most of what we have shipped to European countries is already TOPCon this year. And then what we see for the future, it's, as I said before, improving the technology. Okay, improving the technology. What are our plans for the coming years with TOPCon? So we have a first stage coming quite soon. It's what we call the TOPCon Ultra. So what this means, what TOPCon Ultra means, is that we plan to increase the efficiency of the cell even further. So it will help us increase even better the LCOE of the projects. And then more in the long run, so also after 5 years in which TOPCon will remain mainstream in the industry, we expect tandem cells to be ready for mass production. So also we expect TOPCon to be used as a base for these tandem cells combined with perovskite. And this is also again related to see how why we see TOPCon for mainstream for the next 5 years, is because it will serve as the basis for the tandem cells with very high efficiencies that we're expecting to come in after 5 years. So I talked about cell technology, but of course, when we look at a product roadmap, we always look at the cell technology, but we also look at the wafer size roadmap. Okay, so this has been a very important topic for us at Trina, because as probably many of you know, we were big promoted of using the bigger cells, so the G12 cell that we started manufacturing in 2020. And then a couple of years after, we were also big promoted of rectangular cells, integrating this type of cells, so the G12R into our portfolio. What we see as a trend is that the market share of this type of cells, for which we were strong believers a few years ago, is increasing, simply because we see benefits on those projects using this type of cells. And here, what you see is how we use them in our portfolio. So it's not a coincidence. We use them in different ways to improve let's say, the customer value of each product, and we use them in different ways. So for the what we call the Vertex S Plus, which are the two first products in our portfolio dedicated to rooftops, we use the smaller cell. And particularly in a smaller product, the 9R, we use it with a third cut. So we do this to reduce the current of our products, increase the voltage, and this combination of high current and low voltage is very convenient for the residential market. So we really do it for that reason. And then on the other side of the portfolio, we use the G12 cell with a half cut for the big module. Why do we do this? Because by using these bigger cells with a half cut, what we obtain is lower voltage for that module. What we're looking is to increase the power per string on the projects to reduce the BOS by reducing the cabling, by reducing the mounting structure costs. So there's a reason why we decided to use this cells several years ago, and it's gonna remain stable in our portfolio because we think that that's the best fit for the projects. And that's it from my side.
Thank you, Mireia. Now, you mentioned there the possibility, well, the TOPCon Ultra and the possibility of another 30 watts on the module output. Could you tell us a little more about what you see as the key innovations to achieving that and how you'll be doing that?
Sure. So three key main things we plan to implement for this ultra cells to improve the efficiency. One is the dual side passivation, so that means passivating the cell front and rear side of the cell. Second one is mitigating the optical parasitic absorption of that happens in the cells, also to increase efficiency. And the third one will be adopting ultra-fine grid. This basically means reducing the busbar thickness to also improve the efficiency of the cells.
And there has been some talk this year about degradation mechanisms potentially affecting TOPCon modules out in the field. Do you see a cause for concern there?
So I think this brings back to what we were saying about TOPCon. Of course, the technologies, we need to use them and manufacture them to notice, right, possible degradations. And we've already experienced this in the industry with PID, many other degradations. UVID, it's a phenomenon that was not that common on PERC, that is much more relevant in TOPCon. And we noticed this a long time ago. So basically what we have done is we have improved the way we manufacture the cells by changing the way we do the deposition, changing the structure of the cells to mitigate the degradation of UVID. So just to give you one example, we recently, a few months ago, tested our two biggest modules against UVID, not what is required on the IC, which is probably not that aligned with what it will be required for TOPCon, but by considering UV degradation of 300 kilowatt hour per square meter, which is, if I'm not wrong, is like 20 times more than what was in the IC. And after even such high amount of UV radiance, we can see degradations below 2%. It was 1.6, if I'm not wrong. So to answer your question, no, this of course was a phenomenon new to TOPCon, but it's something that is already under control.
Mm-hmm. Thank you, Mireia, for joining us this morning. It's been a pleasure.
You're welcome. Thank you.
And we head now into our final presentation before this session's panel discussion, and that comes from Chaowei, R&D Department Director at LONGi, with a look at hybrid passivated back contact technology. Chaowei, welcome, and over to you.
Hi, everyone. Good morning. I'm waiting for my slides. Yeah, so in 2024, this year, we as R&D people working in Central R&D Institute in LONGi in Xi'an, we set up a few new world records for cell efficiency conversion. We published several nice papers, but we're also introducing our HYMO 9 and HYMO 10 products into the market based on BC technologies. So we're also facing one big challenge and also questions from the market that when BC will become a mainstream technology and the BC modules become a mainstream solar PV product. So my talk would be focusing on BC crossing the chasm. So we did a lot of innovative works on developing the high efficient solar cells. And now we are seeking early adopters in the market. Actually, this year, we have seen BC module installation growing, and we are trying our best to make BC technology a early going into the early majority stage. So between this, there is a chasm. So basically a adoption gap. Starting from this year and early next year, we are at this very critical stage. So let's go back to review the PV technology development and deployment adoption history. So we have set this net zero emission by around 2050 to 2060. And solar PV is a very important and even core renewable technology to meet this target. And starting from early this century, the PV industry introduced aluminum back surface field technology into the market, whose efficiency is generally below 20%. And after several years, incremental improvement, the cost reached about $0.5 US dollars per watt when PERC starts taking up the market. And because at that time, PV was still a very expensive product for the customers. So the feed-in tariff started in Germany and many other countries. This policy, this framework, accelerated the PV adoption in the market. And then after a few years, starting from 2016, PERC is taking over the market. And soon, around 2019, PERC became the mainstream technology. So based on two things, firstly, higher efficiency, then lower cost. So in the past few years during the PERC adoption period, the efficiency is about, I'm putting here the record cell efficiency, which means basically is a limit for different solar cell structures. So less than 25%. And during the PERC period, the solar PV technology generally reached the grid parity starting from maybe early 2010 in Europe, and then starting from 2016, the grid parity was reached in globally majority countries. And that's why we have witnessed about 1 terawatt global installation 2 years ago, because of the introduction of a PERC product into the market. So about 1 or 2 years ago, starting from we have went through the wrapping up of TOPCon technology, higher efficiency and also lower cost. And after TOPCon, especially starting from this year, we have seen about this year 2 terawatts global installation of PV modules. So starting from TOPCon taking over the market share very quickly because of one very important reason that after PERC we have established a very mature PV industry. So basically, starting from aluminum BSF to TOPCon, the industrialization of silicon PV technology has completed, and all the solar cells are based on a front and back contact structure. So next, why we are introducing BC into the market, because it is already demonstrated a higher efficiency, and we believe that based on the mature PV industry, we have all demanded resources to cut down the BC technology cost. And also, we are kind of entering into a new state of PV technology. We are accelerating PV adoption globally to meet net zero emission. So next, before it was the industrialization of silicon PV technology, and starting from this year and the next year, we are going through I put a word here, a PVization. So we want to see PV adoption in many industrial and residential sections, so that we can quickly meet the net zero emission. So after BC, at this moment, we believe BC is the ultimate silicon PV technology, because we don't see any other single junction silicon solar cells that can demonstrate a higher efficiency. In comparison to FBC structures, take TOPCon for one example, BC cells shows a higher efficiency, higher scalability. That's because BC can adopt a copper material very easily, and the front side of TOPCon metallization using non-silver material is very hard because of the lack of firing process. Manufacturability is a little bit hard because it's a complex manufacturing process. Reliability, we don't see any obvious difference. In terms of circularity, we at this stage believe they are similar. So the challenge for BC is a complex manufacturing process and higher costs, where we see our chance in establishing our competitiveness. So let's take a look at this figure published in JOE by the researchers that looking back several years ago, like 10 years ago, we foresee a very rapid growth of IBC structured solar cells taking over the market share. But over the past years, that didn't happen, and we kind of lowered down our expectation for this technology. But like I mentioned, that's because it's a complex manufacturing. And we believe the industrialization of PV has finalized, and we have enough source to accelerate, to cut down its cost. So we believe we will accelerate its adoption in the market. Like what happened in the case of polycrystalline, multicrystalline silicon to silicon, monocrystalline silicon wafers. So we have established a BC platform, and we are going to introduce BC technology-based products into the market. And we are seeing the growth annual production capacity to around 3 terawatts to meet the demand for PV technology in net zero emission and the PV application in many segments.
Okay, Chaowei, we will have to cut off your presentation there as we are running out of time. Please do stay on the line. Please do stay on the line, though, as we head into the final part of this session. And that final part is, of course, a panel discussion where we are taking in some of the points raised so far today and looking at where solar cell and module technology is going, and what innovations and introductions we might see in 2025 and beyond. joining Chaowei, R&D Department Director at LONGi, who you just saw speaking. Please also welcome back Johanna Bonilla, Head of Technical Product Management for Europe at JinkoSolar. And also joining for this discussion, we have Molly Morgan, Senior Research Analyst with Crew Group, and Sebastián Bonilla, Associate Professor in Materials at Oxford University, and no relation to Johanna, I understand. Welcome all, and thank you for joining this panel. Now, it's fair to say, I think, that 2024 has provided a pretty challenging environment for cell and module manufacturing. And I'd like to kick off this discussion by asking each of you how you see that affecting innovation in the sector. And I will put that question, first of all, to Molly.
Thanks, Mark. Yeah, it's definitely safe to say that it's been a challenging year for manufacturers, which all kick-started back in 2022 when production vastly outweighed end demand for modules. But I think with manufacturers going into quite a cash conservation mode, this has meant that there's been maybe a slight reduction in R&D efforts, so innovation may have slowed, but given the all the efficiencies and the impressive performances of products and product offerings from manufacturers throughout the year, it's safe to say that innovation hasn't stopped. And I think that this will only speed up again as overproduction starts to return towards those sustainable levels of overproduction that we've seen towards the end of the year and we'll hopefully see into 2025.
Okay, and Johanna, maybe to you now. How do you see kind of innovation in this challenging market environment?
Well, for sure it's challenging. It has been a challenging year, but I always believe innovation thrives under pressure. So we have a challenging environment that have put us and push us and all the manufacturers to focus on improving efficiency, reducing costs, addressing specific pain points, I will say, especially related to materials. And maybe, the innovation have been slowed down at the mass production, but for sure in R&D, there are many steps that are just waiting for the right moment. This is my perception regarding that.
And now, Chaowei, the same question. How do you see kind of innovation in the current market environment?
So I've been working in the R&D sector of LONGi in the past 3 years. So innovation, we can see, is very important, especially in this stage of PV technology development. The industry has a different technology, heterojunction, TOPCon, and BC structured solar cells that are going into the market. But that was quite different, like in PERC period, you have the PERC technology taking over aluminum back surface field technology. So every company, including Tongwei, Jinko, and Trina, are putting a lot of efforts into R&D. We kind of establish our competitiveness based on solar cell technology is the core of the future PV industry for every company.
And finally, Sebastián, you're perhaps a little further away from the market in your research, but how do you see PV technology currently, and how does this kind of tough market environment reflect in your work?
Yeah, thanks, Mark. So I think that there is certainly such difficulties with price competition and the amount of cash that companies can invest in R&D. But there is, I don't see too much of a slowdown on innovation because, as several speakers have already pointed, the drive for improved solar technology is ultimately what keeps most of these companies essentially producing and selling more products, because they can essentially provide or plan that they can have a better product. So I think it's a hugely exciting sector. And also you can see from the talks before that there is huge room for innovation in materials, in the cell architectures, in the way that you assemble modules. All of these things are really exciting. And so we're certainly at a point where Some people have already reported over 30% efficiency. Okay, it's lab scale, but then the trick is how are we going to make that into products? And when you look at the theoretical efficiencies that we could get to, I think that we have a very long road ahead, because we could start to look at how are we going to cross the 40% barrier and what it's going to take to bring that to terawatt scale production. So I think that we're certainly in an exciting moment, despite the financial difficulties of the toughness of the marketplace.
For now, as we've heard in earlier presentations in this session, TOPCon accounts for the largest share of the module market. Can this technology continue to? Is there still headway to improve it? I think Johanna, you're probably best placed to answer that first.
Well, TOPCon has a robust foundation. This is clear. Its efficiency, its compatibility. Mireia mentioned also the existing production lines, the experience that we have collected have brought our industry to the level that is a maturity stage of technology. And of course, future advancements are essential for TOPCon. And I will say innovations in passivation layers, reducing reflectivity, what I mentioned during our discussion, will bring us to another level and to stay in the market until we see the need of new technologies as a normal industrial process. And then we will have tandem and other technologies. But until that, TOPCon accounts for a larger share, and it will remain like that at the least for the next 4 or 5 years.
Mm-hmm. And Chaowei, of course, LONGi has taken a slightly different route to TOPCon technology. But I mean, how do you see this market share? Do you expect TOPCon to be around for a lot longer?
So basically, I kind of, starting from the point of view of academic research, so TOPCon and BC technology are not in the same category. So we are basically competing with front and back contacted solar cell structures. BC is just a solar cell structure. So we are also using TOPCon technology in our BC solar cells. So we also believe TOPCon passivated contact has big potential for higher efficiency. And we're making it in the BC structure cells, which so far have one very definitive advantage in comparison to front and back contact solar cells, which is a fill factor. So good passivation, we have similar open circuit voltage, and using very fine front grid on TOPCon front side, we have comparable short circuit current, but fill factor, so far, BC is always superior than front and back contact solar cells. So we believe in that BC structure, and also we adopted the TOPCon technology in our solar BC structure. That's my point of view.
Uh-huh. And Molly, when you kind of look at the market, how do you see the kind of expectation for TOPCon?
Yeah, you're absolutely right that TOPCon is leading the market at the moment. And at Crew, we forecast it to have achieved around 60% of the market share in terms of production in 2024. And with TOPCon, we forecast that this is only going to continue to increase over the next few years. And we see it sort of reaching around 80% before gradually declining out towards the end of the decade to make room for back contact to take its share of market share, and then in the 2030s, eventually tandems.
Mm-hmm. And how does this reflect, kind of, Sebastian? What's coming through your lab? Do you still see kind of headway for more improvements on TOPCon cells, or is the kind of R&D sector focused on other areas already?
I think in most universities, we're probably focusing on what Molly says is the technology of the 2030s, certainly because a lot of the improvements that you can make on TOPCon and front and back contact, I think that Chaowei's point is very good about the different categories, right? So you can apply TOPCon both contacts at the back, and you can still make a lot of improvements. But most improvements in TOPCon and heterojunction are very much based on the production line, on improvements of the production line, because the research has already demonstrated how all of these things are done, right? We know how to make heterojunctions, we know how to make the polysilicon, we know how to improve the contact properties. So in most academic labs, I think that the focus is a lot how to bring an architecture of either TOPCon or heterojunction into tandem and demonstrate that it can become a product. And that, of course, has to do with reliability. That would be my
Sure, and well, talking actually of reliability, that brings us nicely to the next point I wanted to make, which is that we have seen some concerns raised this year around long-term reliability and particularly ultraviolet degradation in TOPCon cells. Is this really something the industry is concerned about? And probably, again, Johanna would be a good place to start with this.
Well, degradation mechanisms, I will say, particularly related to radiation and thermal stability, are under scrutiny. However, the industry is addressing this through enhanced material. It was mentioned in some of the presentations before. Process optimization, so especially related to passivation techniques, they can reduce the defects on bulk quality. I think something was mentioned before is UVID. This particularly is associated to TOPCon, but we see that this phenomenon causes temporary performance losses. So over the time, the changes may dissipate, especially at very simple operating conditions with light exposure, for example, which is a normal operation of a module. So I believe that we have paid a lot of attention from the industry level in the selection of materials, especially encapsulation plays a key role, and passivation quality. So these are solutions to mitigate those defects. And I will be very honest to say, before we launch at mass scale production, but in 2021, 2022, we experienced already certain phenomena in our R&D that we control through material selection. So this is key for such what we call degradation. In some cases, I will not call them degradation, but temporary performance losses.
Mm-hmm. And Chaowei, at LONGi, have you seen concern over degradation and long-term reliability in TOPCon in particular?
So firstly, because TOPCon has a very big capacity, we really need to pay attention to the research results coming from maybe different manufacturers. We always believe that tier 1 companies can produce very reliable products. Secondly, that the UV degradation could be the first time that we have went through the degradation in the perovskite cells, but we improved the silicon wafers. This could be the first time that we have a degradation from. We have a very good quality paper, a very good quality silicon wafer, but the degradation comes from the passivation thin film layers. So this is quite different from previous experience. That's my point of view. And I have experience with thin film passivation based on my understanding of this thin film deposition process. This can be solved, but we have to pay a lot of efforts into process control.
Mm-hmm. And Sebastian, do you see in your lab, a need for improvements in TOPCon reliability? Is there still work on that in the R&D space?
Absolutely, yeah. I think Johanna's point is very good about this. That is not necessarily a degradation. That it's let's say something that is already unusable. Is simply that the performance is degrading over time, and certainly. So when we look at solar installations, what we want is the most amount of energy, and so minimizing that rate of degradation is certainly a very important factor. And at the end of the day, most of these degradation mechanisms come from a physics understanding of the materials, right? So certainly something that loads of people are interested in, and there's some fantastic work coming out of UNSW, Fraunhofer ISA very recently, where they've seen what are the reasons that that some of these modules are degrading faster than others, and so improving those materials, like Johanna was saying, is pretty important and pretty key for providing the most amount of energy that we can in the span of time that we can use the modules.
And then we come to Molly. Do you see in the market, do you see concerns over the reliability of TOPCon?
I think there's quite a few concerns about reliability and general quality control at the minute, with manufacturers understandably trying to reduce costs and cut corners where they can. So we do see a lot of conversations as analysts of people in the industry trying to understand how severe these issues of stability, like the UV-induced degradation, and general quality concerns like frame thicknesses. We do get a lot of questions trying to understand how severe and how widespread these issues are.
Mm-hmm. And well, in 2024, aside from TOPCon, we've also seen quite some growth in back contact technologies, and these kind of starting to pull away in terms of efficiency as well. How much further, first of all, can this performance be pushed? Chaowei, I think I will go to you first on that.
Sorry, I didn't get your question.
Oh, sorry, just how well, I guess where is LONGi now in terms of efficiency with back contact technology, and how far do you think this can go?
So we have set about 27% cell efficiency based on both TBC cell structure and heterojunction back contact cell structure, and we are aiming for 28% the next year. That's possible based on our R&D progress. And your point is right that high efficiency comes at a cost. Meanwhile, we are shifting a lot of efforts into cutting capex and also the manufacturing, the processing complexity. We are doing both.
Sure, thank you. And Molly, how do you see the kind of potential for back contact technology?
Yep, so at Crew, we do forecast efficiencies internally for the different module technologies, including back contact. And as just one part of this, we take into consideration manufacturer roadmaps. And it is always interesting to see manufacturers stating how and when and how close they think they can get to these theoretical limits. And like Chaowei just mentioned, there are some impressive cell efficiency roadmaps out there. And ICO is another one that I've looked at recently, pushing these, pushing above 28% for cell efficiencies in the next few years. So there's definitely more headroom to be achieved with back contact efficiencies before the end of the decade. But these might just not be quite as rapid as the impressive efficiencies we've seen in 2024.
Mm-hmm. And Sebastian, do you see a lot of work at the moment in back contact technologies?
Yeah, I mean it's a really interesting question, because of course when you're thinking about the next generation towards plus 30% with tandems, you want to think what is the technology that can lie on top, right? So if it's a front and back contact, that's the most straightforward with a two-terminal tandem. But we also consider what happens when we have a back contact technology now completely taken over the market, maybe by the end of the decade, as Molly was saying, and then how do you put a tandem that sort of mix well with that? So certainly the back contact, we should think a little bit about it. And also the possible improvements in the manufacturability. So going back to Chaowei's presentation, there are clear advantages that we know we can get more efficiency out of a back contact. But then it becomes a matter of, can we actually produce that at a sufficiently large scale and sufficient reliability and so on. So maybe addressing some of those factors also becomes a really interesting area of study.
Mm-hmm. And Johanna, finally, you have, well, obviously Jinko is sticking with TOPCon for the moment, as you've said. Have you looked at back contact technology, and how do you view this?
I like the question because I always say in R&D we look at many things, and this is the fact. Certainly, it has potential for higher efficiency. I mean, we cannot deny that not having shading in the front is a technical advantage, clearly. And this elimination of the losses is key for future developments. However, I think there is a lot of work in the complexity and the cost of bad contact manufacturing, high precision alignment, unique metallization requirements, automation, the process improvement. We do believe this is a potential a technology, but we have certain concerns, and in these terms I can say Jinko is conservative for mass scale production, so we really need to have innovations that are suitable for a controlled mass production before launching. This is our concern, and I talk from our experience. And of course, there's a potential there, and I think it was mentioned already by the colleague from LONGi. Pushing efficiencies closer to 30% is something that have an advantage for sure, but there are improvements in passivation, recombination rates that needs to be worked for mass production.
Well, yeah, so I think both our manufacturers on this panel have mentioned that back contact comes with a somewhat higher degree of difficulty to make. And I think for now a slightly higher cost as well. Chaowei, could you comment on the cost of back contact manufacturing and how close that is to other silicon technologies today?
So one point I want to I can confirm that the cost of ramping down progress is way more faster than we can expect it. That happened because of the very, like I mentioned, well-established PV industry, very strong capability to introduce a new silicon cell technology. So from this, so we have BOM. So the bill of material BOM is if you calculate the BOM of different silicon solar cells. So basically, apart from silver, they are comparable. So one important cost burden is from the CapEx. So that will be improved by the entire PV supply chain. So we have this PV ecosystem, well-established supply chain, and that's why we believe we can achieve lower cost, and we are doing that, and we believe it's happening, and we will see next year.
And Molly, do you still see a cost gap between? Excuse me. Do you still? I'm gonna have to have some water.
I think I got the question. If you want me to dive
no, please, yeah, go ahead.
So we do still see a cost gap, and the importance of the cost gap is quite large, because that is kind of the key. One of the key blockers of a rapid technology transition, because we see technology transitions occur when a technology can offer a comparable or an improved performance at a comparable or cheaper manufacturing cost. So while back contact still does sit higher in terms of its manufacturing cost, it's going to or while it's not cheap enough to offset the improvements in efficiency, it's going to hold back the technology slightly and stop it from really knocking TOPCon off its pedestal of great market share.
And the other player here, of course, is heterojunction. That's taking some market share at the moment. I think, well, first of all, Sebastian, do you still see improvements in heterojunction coming through kind of labs?
Yeah, of course. I mean, we saw the world records from LONGi. I mean, Chaowei maybe can speak more about them, but essentially, heterojunction was entirely transformed by the advances of these nanocrystalline new layers, right? So getting to the JSC that most other technologies TOPCon or PERC-based can get to was essentially due to these new nanocrystalline layers that we can use. So certainly lots of interesting improvements, and of course then becomes a matter of how are we going to structure those layers to make them into a possible back contact structure, either by this new laser technology in LONGi, or there are other possibilities that have also been reported in the past. So I think that there is certainly enough efficiency to be squeezed out. And I think Chaowei, said that there is a reasonable target of getting to around 28% efficiency. And I think simulations that we've done back that up. So I think that is certainly possible, yeah.
Mm-hmm. We are just about out of time now. Maybe Chaowei, quickly, could you say any more about heterojunction and LONGi's work in this area?
So actually, I love heterojunction technology because you can imagine heterojunction solar cell structure is requires most minimal steps to fabricate. But the major problem is the equipment to fabricate the solar cell is expensive. So and also heterojunction based perovskite tandem is also shows very high efficiency, highest efficiency so far. So it's also very good bottom cell technology for perovskite tandems. So we'll see, maybe heterojunction will come back when the perovskite-silicon tandem solar cells has solved its stability issues.
Well, I think that is a great and clear statement to wrap up this session on. Thank you once more to our four panelists this morning and our presenters as well for your time and for sharing your insights in this year's PV Magazine Roundtables Europe. One thing that's clear from all the discussions in this session is that despite all that's been achieved already in solar technology, there's no end in sight for innovation and optimization all along the solar supply chain, and a lot of exciting new technologies to look forward to in 2025 and beyond.
Hi, what Mark and my colleague Mark just wanted to say, please do check out our magazine as well. We do have a fantastic December and January edition that is out this week, and it covers a lot more on cell technology innovations, as well as our 2024 PV Magazine Award winners. So I'm just gonna say thank you, Mark, again. Our excellent colleague Marian Veloon is moderating the next session, which looks beyond cells and modules to assuring quality and long-term performance in electronic BOS components. Speaking of excellent colleagues, later on during the lunch breaks, my colleagues organized networking sessions for you. PV Magazine Germany editors Sandra Enkhardt and Jochen Siemer welcome Lennart Wilkening from Soena in the German networking session to discuss wie vermarkte ich meinen Batteriespeicher, so they're focusing on battery storage systems. The English networking session is hosted by our editor, Planet O'Day, who has invited SolarMonkey to speak about the net metering situation in the Netherlands. So before we head on, pick and choose one of these networking sessions. We either have a German or an English one. Meet your fellow attendees and continue the discussion off stage. The space is limited to 45 people, so be fast. But before we're heading into our lunch breaks, it's now time for our session 4, Quality Connection, Attention to Detail in Electrical BOS Components, with experts from Scholz, Technologies, Belectric, and more coming up right now. So don't go away.